Fine, good afternoon to you all students. Hi students, how are you? I hope you all are fine and you all are doing well. I hope by God's grace you all are safe. So pray to God daily for your health, your studies, your parents, your food, each and everything. Okay students? So warm greetings to you all students. Welcome to our today's online class. So this period is computer science for you. Okay, so now we are studying about chapter 4, algorithmic strategies, isn't it? So before I am going to start about today's portion, just recall what are things I have taught at the last class, isn't it? So now from last two class onwards, we are studying some algorithmic techniques, isn't it? So what are the algorithmic techniques we are studying? So each and every class I am telling, isn't it? So this algorithmic techniques are very important and expected 5-mark questions. Among that, I have studied two important most expected 5-mark questions you have studied. What are the two important 5-mark questions you have studied, students? Linear search algorithm and binary search algorithm. Isn't it? So listen. So please write, once you are studying this algorithm means please study it. First read the example, understand the example, then study the pseudocode. Then only you will get understand easily. Okay. So after studying, you should write and see this type of questions in your notebook or any rough note. Understood, students? Okay. So till now you have studied searching algorithm, isn't it? So what is the meaning of searching? Searching means you are going to find something. Already lot of elements or lot of, for example, a bottle contain full of chocolates. You got, okay. So that bottle will contain full of chocolates. Among that, you are going to take any one of the chocolate or your favorite flavor chocolates. So among that lot of chocolates you are searching from the total number of chocolates and you are taking your favorite chocolate. Okay. So already lot of elements are there. From that you are going to search any one element. So that is called searching. Okay. So for the two types of searching algorithm you have studied. What are the linear search and binary search, isn't it? So today onwards we are going to study about sorting techniques. So what's the difference between searching and sorting? So what do you mean by searching? And already I said. So you are going to find or searching or anything from the thing, isn't it? Value. Sorting means already some values will be there. You are going to arrange in an order. Arranging maybe that values in a particular order. Maybe either in ascending order or in a descending order. In one order, you are going to arrange the elements. So that is called which technique? Sorting techniques. Understand? Listen. So today you are going to study next important algorithm is bubble sort algorithm. Okay. So what's the important question? Next important question, bubble sort algorithm. Okay. So it is a sorting algorithm. First point, please now itself study. It is a sorting algorithm. Till last class. So you have studied searching algorithm, isn't it? So in the first line you need to write which one. It's a type of searching algorithm, but it's a what type of sorting algorithm. Okay, bubble sort is a which algorithm? Sorting algorithm. So listen carefully. Here also lot of values you have stored in the list or array. Okay, so here always the algorithm starts at the beginning of the list. So yesterday you have studied binary search algorithm. There you have studied binary search. The searching starts from the middle of the element, isn't it? Isn't it on a bubble search algorithm? Searching starts from where? Middle, isn't it? But this bubble sort algorithm starts from where? Beginning of the list. Always the sorting starts from where? Beginning of the list. Okay. Then after sorting, you have stored what? Value stored in. That means listen, algorithm starts at beginning of the list of values stored in an array. Total number of values you are storing in an array. So in that values you are starting from what? Beginning of the list. Okay, how this algorithm is working means listen. So it compare each pair of adjacent element. So each, what do you mean by pair? Pair means couple or two, isn't it? So each time you are taking two elements. Okay. So from the starting onwards you are taking two elements. Then first you will compare first two element. Okay. So whether which one is greater. Okay, so likewise you are comparing each and every adjacent pair. Adjacent means next, that means next element. First means next element second. Then second means next element third. Likewise, adjacent element you are what? Comparing. Okay, so comparing each pair of adjacent element and swaps them. So what do you mean by swaps them means you are going to arrange the element in some order. So swaps them means changing the place. Okay, so for example, first element is smaller, second element is greater. So no need to swap. Compare, first element is greater and second element is smaller. So you need to swap. That means change the place. Second element needs to come in first thing and first place will go to second. That is called swap. Okay, now read the point. So it compares each pair of adjacent. Adjacent means what? Next element, that is nearby element, and swaps them. Okay, so and you are going to change the place if they are unsorted order. That means if they are not in order means you are going to want swap the element. Okay, so likewise you are going to swap each and every element till no swaps are needed. No swaps mean till once you find the array is arranged in some order, maybe ascending order or descending order. So your array is arranged in some order. So you will think, yes, hereafter no need to swap any element, or hereafter no need to change the place of any element. So till that you need to swap. Understood? Now read the point. So this comparison has to be continued until no swaps are required. So till you need to continue, your swaps need to continue until no, that means you are not needed to or no needed to arrange any elements in an order. Okay, so here the name of the algorithm if you are seeing is bubble sort. Why they are giving the name bubble means if you are seeing the diagram. So next you are going to see the picture of that, the example diagram. So you are going to swap the element means you need to put bubble in the, that means circle or bubble in the element, and you need to put an arrow mark, that is a bubble. Okay, so listen, what are the points you have studied once? Remember it? It's a symbol. Bubble sort is a symbol sorting algorithm. So this algorithm always starts at which point? Beginning of the list. So already the values are stored in an array. In that values you are going to starting from, or sorting is starting from what? Beginning. So how this algorithm will work? It will compare each and every element, that is the nearest element, adjacent pair of element. So till when you need to continue, so till no swaps are needed. That means it will compare each pair of elements and swaps if they are in unsorted order. If they are not in arranged order means you need to swap the element. Okay, so this comparison will continue till you are telling, till you know whether no swaps are ordered. Otherwise you are thinking so all the elements are arranged in some order. So till that you need to swap. After that no need to swap anything. Okay, so why we are calling the name as a bubble means, so you are showing something in a bubble and drawing a arrow mark at the top. Understood? Okay, so what's the next thing? Algorithm if you write means what's the next step? So you need to write the pseudocode or procedure, isn't it? Okay, so this algorithm already you have studied. The algorithm or the sorting always starts with which element? First element or beginning. So always if you are storing some elements in an array or a list means, so the elements will arrange based on which one? Index values, isn't it? So index value always starts with what? Starts from 0. Okay, so always your search will start from which element? First element. So first element means what's the index value now? First element means what's the index value? 0. So index equal to 0. Okay, so now your current element is first element. So you are comparing your current element with the next element. What's the next adjacent element? Index equal to 1. That's the next element. So first you are going to start from the first element. What's the first element index value? Index equal to 0. Then you are going to compare the first index value to the next index value element. Okay. So once you are comparing, if your current element is greater than next element, that means maybe for 1 and 2, index place 0 and 1 you are comparing. So index place 0 is greater than index place 1. That is first element is greater than second element means you need to swap them. That means first element needs to come in second place and second elements need to come to first place. Understood? That only they are giving. If the current element is greater than the next element means you need to swap them. Okay. So if the current element is less than, okay, first element is less than the next element, means what you need to do? So no need to swap, you need to move to the next element. Understood? So if the current element is less than the next element means no need to swap, you need to move to the next element or right side. So this step will continue till once you get the sorted array. Understood? So what is the pseudocode? So always your search tree starts from the first element. What's the index value? Start element means 0. So you are going to compare each adjacent pair, that is nearest element. Okay. So comparing with each current element, that is next element. So if the current element is greater than the next element means you need to swap them. If the current element is less than the next element means you need to move to the right side of the next element. So this will continue till you are getting a sorted array. Understood? See the example, then only you will get understood. Okay. So they are giving some element 15, 11, 16, 12, 14, 13. Okay. So these elements you are going to sort using bubble sort algorithm. See the diagram. So first you need to write all the elements in a just like this tabular column. So diagrams and all, each and every algorithm you need to draw the diagram as it is. Listen carefully. So always your search will start from where? First element, isn't it? So and what's the next step? So it will compare the first element with the next element or adjacent next nearest element. So first two elements, see, compare 15 and 11. See the next diagram, 15 and 11. So 15 is greater than 11, isn't it or not? Yeah. So 15. So which are the elements you are going to sort, or which are the elements you are going to compare? That element you need to round it and you need to mark it and show. Okay. So for the diagram also you need to put a circle and shade it. Okay, so listen. So 15 is greater than. So here they are giving 15 first step. 15 is greater than 11. So you need to interchange. So 15 needs to come in which place? Second place. 11 needs to come in first place. So only they are giving 11 is going to first place and 15 is coming to second place. Understood? See this next diagram. Okay, first two elements over. Then listen. Then what's the next? 16 and 12. So next you compare 16 and 12. So which one is greater? 16 is greater than okay, 15, 11 and 15 over. Okay, so listen, next element 15 and 16. See the next step, 15 and 16. So 15 is whether less than 16? No, isn't it? So yes, 15 is a smaller number, so no need to swap. See the next line, 15 is less than 16, so no swapping. So no need to swap this two. Understood? Okay, then you compare the next two elements. What are the next two elements? 16 and 12. So 16 and 12 means which one is greater? 16 is greater. So 16 is greater than 12. So you need to change. So 12 needs to come here. 16 needs to come to the first place. So see the next diagram. So 12 is coming here and 16 is going here. Then you need to come back next 16 and 14. So which one is smaller? 14. So 14 needs to come here and 16 needs to come there. Next 16 and 13. So next one. See 13 needs to come here. Again 16 needs to come here. Okay. So this algorithm will work till you will get the sorted array. So now see the element 11, 15, 12. So it will work still. So it will repeat. Once it over, no? Again it will repeat. Again it will repeat. Next it will compare 11 and 15. Which one is smaller? 11 is smaller. No need to swap. Next it will compare 15 and 12. Which one need to come at first? 12 needs to come at first. Then 15. 15 and 14. Which one needs to come? Likewise. So it will compare each and every element once you get the sorted array. What's the sorted array value? Say 11, 12, 13, 14, 15, 16. So till you are getting the sorted array, this like step will continue. Understood? Understood the working of bubble sort algorithm? Okay. So next sort algorithm is selection sort. Okay. So what's the next sorting algorithm? Selection sort. Next important 5-mark question. Okay. So why you are introducing the selection sort means to improve the performance of bubble sort. Okay, so compared to that bubble sort algorithm, the selection sort performance is somewhat good. So to improve the performance than which one? Bubble sort algorithm. So you are going to introduce which algorithm? Selection sort. So here in selection sort you are making, listen carefully, each step you are going to change only one pass or only one exchange. Understood? So each and every step you are going to change what? Only one exchange for every pass. Now read the first point. So selection sort algorithm is which algorithm? Sorting algorithm. Okay, why they have introduced? To improve the performance than the bubble sort algorithm. So they have introduced which one? Selection sort algorithm. Okay, so in this selection sort you are going to make only one exchange. So each and everything you are making what? Only one exchange for every pass. Okay, so listen. So how this algorithm will works means, listen. So this algorithm will find smallest element. So there bubble sort you are going to compare only nearest, that is pair, nearest element, isn't it? But here selection sort not like that. whole elements you are stored in a list. From the whole elements, you are going to find which one is the smallest element first. Okay, from the whole element you are going to find what? Which one is the smallest element, and you are finding this is the smallest element means next step you will bring that element to the first position. Understood? Okay, so first element over. Then you come. Then next you are going to find which is the second smallest element from all the elements. So next you are moving the second smallest element to the second place. Okay, then third element, then fourth element. Likewise, you are going to continue till you will get a selection sort. That means till you will get a sorted element. Understood? Now read it. It's a simple sorting algorithm. Why they are bringing? So it will improve the performance of bubble sort by making how many passes or how many exchanges you are making for each pass, only one exchange. Okay, how this algorithm will work? This algorithm always will find the smallest among all the elements. It will find smallest in an array and it will bring the smallest element to which place? In the first place. So after the first place, you place the element. What's the next step? Next it will choose the next smallest element. So next it will swap them and place in the second step, and next come to the third. Likewise it will continue till the, see, then it will find the second smallest and swap that element with an element in the second position. So it will continue until the entire array is sorted. So this step will continue till you will get a sorted array. Okay, so this algorithm will repeatedly working till the next smallest element. Okay, so each pass it will keep what? Next smallest element in that place. So we can call as a what? Selection sort. Understood? Okay. So next you need to write the pseudocode, same only. Okay, so here also the sorting starts from which one element? Index place 0. So you are going to search the which is the very smallest element in an array. Okay, so with that smallest element you need to keep it in which place? First place. Okay, so after that next we move to the which element? Which place? Second positions or second element. Okay, so next you are moving to the second smallest element and keeping in which place? In the second place. See, next we move to the second element and look for the smallest element present in sub-element. So that's in that array which is the next smallest element. Okay, so from the first index to last index you are searching. So next you are going to replace the second smallest element at the second position. Okay, next you are going to second, if you find the second smallest element means, so in the second place you are replacing the particular element and you are keeping the second smallest element. So this step will repeat it until you get the one? Sorted array. Understood the pseudocode? Okay. So see the example, then only you will get understand. Okay, see the example. So here also they have given some values. 13, 16, 11, 18, 14, 15. Okay, so selections are how you need to draw it. So this is the initial value or initial array. So you need to write all the values as it is. Okay, see 13, 16, 11, 18, 14, 15. Okay, so all the values you need to make as a small rectangle shape. Okay, rectangle box inside you need to write. Same you need to draw for your exam paper also. Okay, so listen carefully. Among that all elements, which one is the smallest? Which one is the smallest? 11. So you need to bring the 11 is the first place, isn't it? So from where you need to move this place? So you need to put on arrow mark. So you are moving what? 11 to the first place and 13 you are moving to that 11th place. Understood? Understood? Okay. Then you find. So among this array, which is the next smallest element? 13. So 13 you need to bring it which place? Second place. See the arrow mark? 13 you are bringing up. So 13 you are bringing. So which element you are bringing? That element you need to put that round corner and you need to note. Okay. So 13 you are bringing to the second place and 16 is coming to the 13th place. Okay. See. Okay. Second also over. Then among this, which one is the very smallest? 14. 11, 13. Next one is 14. So 14 you need to bring to which place? Third place. Okay. So 14 you are bringing to the third place and 16 you are bringing to the 14th place. Okay. Then among this one, which one is the smallest? 18, 16 and 15? 15, isn't it? So 15 you need to bring to the 18th place and 18 you need to bring to the 15th place. Okay. Next. So next which one is the smallest? 16 and 18? 16. So 16 needs to go to the first place and 18 needs to come. So now see the final one. 11, 13, 14, 15, 16 and 18. Isn't it? Now you get the sorted array. But bubble sort is not like that. You need to compare all the two elements each time. So if you are comparing likewise two elements each time means the step will go on increasing. Each time you need to compare and each time you need to make a pause, isn't it? But here selection sort, if you are seeing means from the whole element only you are going to sorting, isn't it? So it will improve the performance when compared to the which array or which algorithm? Bubble sort algorithm. Understood? So today you have studied two important 5-mark questions. What are the important 5-mark questions? Bubble sort algorithm and selection sort algorithm. Okay. So please understand the concept and study each and everything. Okay. If you have any doubt means please when you are interactive session period you can ask to me. Okay. So 4 questions you have studied. What are they? Linear search, binary search, then bubble sort and selection sort. Okay, then one more algorithm is there that tomorrow I'll take class. Okay, that algorithm. Please don't waste time, students. This algorithm and all you should study, write it and see. Okay, don't waste time, students. Thank you. Take care. Thank you.